All right, randomness and probability. So basically just what's the definition of probability in this one. Here's some examples of things you're going to learn in this chapter. Toss a coin 10 times. How likely are you to get a run of 3 or more consecutive heads? An airline knows that a certain number of customers who purchased a ticket will not show up for a flight. So if the airline overbooks a particular flight, what are the chances that they'll have enough seats for the passengers who show up? Or a couple plans to have children until they have at least one of each gender. How many children should they expect to have? So, a big fact, yeah, it could be a lot, you never know. Big fact emerges when we watch coin tosses or results of random sampling and random assignment closely. And I would write this part down. Chance behavior is unpredictable in the short run, but has a regular pattern in the long run. This remarkable fact is the basis for the idea of probability. Okay. So we're going to look at if we toss a coin a bunch of times, like short run and long run. Okay, so let's say that we toss a coin 10 times. Oh, okay. You gotta get out of Smart Notebook too. Okay, 10 times. So we toss a coin and we're gonna find out what the proportion of heads is. All right, so we only had 3 out of 10 that were heads, right? Because we only flipped it 10 times. The expected probability is 5 or half, right? Because it's a 50-50 chance. But 10 tosses is the short term, right? So what happens if I add 100 tosses onto that? Let's do 100 tosses onto our 10 tosses. Look at it go. That was terrible. It's supposed to get closer to 50%. It got like a barely closer. So 0.39, let's do another 200. See if I can get closer. All right, so we're closer to 50%. So what I want you to notice is in the short term, you have a lot more variability, okay? There's a lot more variability in the short term. But the more and more we do this, we see that that probability is going to even out to 50% of the time that that happens. Back to normal zoom. So we might expect that a coin has a probability of coming up heads just because the coin has 2 sides, but we can't be sure. In fact, spinning a penny on a flat surface, so if you like take the penny, you know, and you flick it, it actually gives heads a probability of about 0.45 times rather than 0.5. I didn't know that. Did you guys know that? Thanks, stats book. How did they know that? They actually did it over and over and over and over and over and over and over, like a ton of times. And then they found out that it's a 0.45 chance if you like spin it. But if you flip it, it's a 50-50 chance, again, in the long run. What about a thumbtack? So let's say you like flicked one of those and you're going to count whether it lands down or it lands with the pin down, point up or point down. So it's actually not a 50% trial just because there's up or down, like heads or tails, right? That doesn't necessarily mean 50%. You would have to flip that thing a whole lot of times to figure out its true probability of landing pin up or pin down. So what is the law of large numbers? If we observe more and more repetitions of any chance process, the proportion of times that a specific outcome occurs approaches a single value. Okay, the actual definition of probability. Most of you guys know the probability of any outcome of chance process is a number between 0 and 1. All right, it either has 0% chance of occurring or 100% chance of occurring, or some decimal or percent in between. Okay, and that describes the proportion of time the outcome would occur. And this last part is the most important in a very long series of repetitions. All right, does anyone in here want to be an actuary? Not one. All right, if you don't know what an actuary is, they do life insurance or health insurance, and they help figure out how much they should charge versus the calculated risk. One of my friends, she went to Baylor with me. She was a national merit finalist. She got a free ride to Baylor, and she majored in actuarial sciences. And I don't think her husband works, and she makes a lot of money, and she worked from Costa Rica for a while. That would be cool. She worked from home. So it's been at the top, one of the top jobs for highest job satisfaction. Just trying to sell this to you if you're interested. In a while. You do have to take a lot of tests. I think you have to pass 8 tests to be fully qualified. But she got paid to study once she got hired. She got 2 hours a day to study that she got paid to study. So just a little bit about that. All right, so here's an example about life insurance. How do insurance companies decide how much to charge for life insurance? We can't predict whether a particular person will die in the next year. But the National Center for Health Statistics says that the proportion of men, oh, you guys know life insurance, right? So if you guys took out some life insurance policy now on you, it would be really cheap. Why? You guys are young, so you're unlikely to die, right? But if you're 75 or over and you take out a life insurance policy, it's going to be a little more expensive because you don't have as much time, most likely. All right, sadly enough, okay? So anyways, National Center for Health Statistics says that the proportion of men aged 20 to 24 years who die in any one year is 0.0015. This is the probability that a randomly selected young man will die next year. For women that age, the probability of death is about 0.0005. If an insurance company sells many policies to people aged 20 to 24, it knows that it will have to pay off next year on about 0.15% of the policies sold to men and about 0.05 of the policies sold to women. Way to go, women. You guys are dying less often on the ages of 20 to 24. Yeah. Therefore, the company is going to charge about 3 times more to insure a man because the probability of having to pay out is 3 times higher. I don't know why more men die from 20 to 24, but I could guess. All right. So anyways, according to the Book of Odds website, the probability that a randomly selected U.S. adult usually eats breakfast is 0.61. Explain what 0.61 means in this setting. So when you're just talking about a basic probability, you always want to include after many repetitions or after a lot of times, all right? Then we're going to get a probability close to 61% of U.S. adults that eat breakfast. It may not be exact, okay, whatever we do, but you're going to get close to 61% if you ask a large sample, okay? So a very large sample of U.S. adults, whether they usually eat breakfast, 61% of them will answer yes. So why doesn't this probability say that if 100 U.S. adults are chosen at random, exactly 61 of them usually eat breakfast? So if you just went to 100 people at random, would you get exactly 61 of them who said that they eat breakfast? No, right? There's variation from sample to sample, and 100 isn't a huge number, right? So any sample will have some variation. So probability is a measure of how likely an outcome is to occur. Let's match the probabilities. This should be really easy for you. So I would like everyone to participate. Your numbers are 0, 0.01, 0.3, 0.6, 0.99, and 1. So which probability goes with this statement? This outcome is impossible. It can never occur. Yay, everyone. This outcome is certain. It will occur on every trial. We're good at this, right? We got this. Okay. This outcome is very unlikely, but it will occur once in a while in a long sequence of trials. I agree. This is easy problems right here. This outcome will occur more often than not. I agree with you. 0.6, more often than not. Yep, that's it.